Hi, I'm excited to present OccAny, Generalized Unconstrained Urban 3D Occupancy. 3D occupancy prediction takes images as input and produces a 3D semantic scene, capturing metric scale, scene completion, and semantics. Existing methods are limited by sensor calibration, camera setup, input resolution, and single domain focus. To address this, we propose OccAny, a unified urban occupancy model that handles monocular, sequential, and surround view inputs. OccAny also predicts segmentation features that can be prompted for segmentation tasks, including instance-level prediction. We make three contributions. First, we adapt visual geometry foundation models to urban scenes for accurate metric scale reconstruction. Second, we introduce novel view rendering with test time view augmentation to infer missing scene content. And third, we propose segmentation forcing, which compensates for sparse LiDAR supervision and enables semantic understanding. OccAny is a two-stage pipeline, 3D reconstruction, then novel view rendering. The reconstruction stage takes images and predicts scene geometry, confidence scores, and segmentation features. The outputs are projected into target novel poses, then fed into the rendering stage, which predicts geometry, confidence, and semantic features for the novel views. Our model is built on the master encoder-decoder architecture with a scene memory token encoding global context. We use a linear head for geometry and a stronger MLP head for richer segmentation features. The encoder is frozen to preserve master's representations. The same architecture is used for both stages, with one exception. The rendering encoder is smaller since its input is already a geometry prediction. Here, we freeze the scene token and fine-tune the rest. We apply three losses: a confidence-weighted point error against LiDAR ground truth, a confidence-weighted MSE loss forcing the model to predict SAM features, and an encoder distillation loss pushing the novel view encoder to mimic the reconstruction encoder. We further push performance with OccAny Plus, which integrates Depth Anything 3 and SAM 3 into both stages. This variant replaces Master with Depth Anything 3, Vanilla Dino backbone, dual DPT heads for geometry, and a SAM 3 head for segmentation. We add a scale invariant distillation loss that transfers depth knowledge from pre-trained Depth Anything 3, helping compensate for sparse, limited range LiDAR. At inference, 3D reconstruction produces poses, point maps, confidence, and segmentation features. Novel poses are sampled from the estimated poses, and novel view outputs are predicted. The 3D occupancy is obtained by fusing both. For training, we leverage multi-domain surround LiDAR datasets with two view configurations, monocular sequences and single-time step surround views. Novel views are sampled during training with probability 0.4. We evaluate zero shot across three scenarios: 5-frame sequence, monocular, and surround, showing strong generalization. Here are qualitative results. From left to right: input, baselines, OccAny, and ground truth. False positives are gray. OccAny predicts more complete scenes and more coherent instances. On geometric occupancy, OccAny outperforms baselines in IOU across KITTI sequence, KITTI monocular, and nuScenes surround with significant margins. On semantic occupancy, OccAny again leads across benchmarks. Among our components, novel view rendering is the most critical. Upgrading to Depth Anything 3 and SAM 3 yields better geometric occupancy on KITTI sequence, but worse on nuScenes surround, though qualitative results improve overall. On semantic occupancy, OccAny Plus with distilled features performs better on nuScenes but worse on semantic KITTI. Using pre-trained SAM 3 directly is much better on both, indicating a gap between distilled and pre-trained SAM 3 features. We also compare on point cloud reconstruction. OccAny Plus significantly outperforms Depth Anything 3 on both KITTI sequence and nuScenes surround in F-score. For metric depth, OccAny Plus surpasses Depth Anything 3 on Delta 1 across both datasets. Finally, one model, any rig, any domain, no camera calibration required. Thank you.